Okay, this is the Math 1113 Zoom meeting, October 27th, 8 a.m. This week we're going to do section 7.1, practice problems, page 578, 3 to 27 odd and 29 to 59 odd. We will have quiz 9 this week on Friday, do Sunday, based on these problems. For WebAssign, we have 1, 2, 3, 5, and 6 only. It's 5 total problems, so just email me the percent of these 5 problems that you get correct. All right, what is going on in section 7.1? Is called verifying trig identities. Simplifying trig expressions and proving trigonometric identities. Okay. You may have seen this in high school trig. Verifying trig identities. All right, we will sort of make the difference between an equation versus identity. All right, an equation like 2x plus 1 equals 3. Okay, is solved for x, and there's like one number answer, or if it's x squared, there's 2 number answer, x cubed, 3 number answer. There's certain numbers that are answers. That are answers. So you have 2x equals 2 and x equals 1, and you have solved the equation. Okay, and identity, I'll start with the first basic one. A sine squared of x add a cosine squared of x equals 1, hopefully. Works for all x. Notice they both have equals, but you do not solve this. Solve this. It works for all x. Let's pick a random one. X is 5.7. Sine squared of 5.7 add a cosine squared of 5.7. Better come up 1. It doesn't matter if you're in degree mode, radian mode. It could be 5.7 radians. That's what I've written down here. Or you could add the degree symbol, make it 5.7 degrees. It doesn't matter. Now, when you actually punch this to show it, sine of 5.7, you have to punch it like this. You don't punch it like this. It reads like, or you punch it actually like this, a cosine of 5.7 squared equals 1. I am in radian mode, okay. So parentheses, a sine of 5.7 and then squared. Actually, I left off a parentheses there, so another parentheses and then squared. There we are. Add parentheses a cosine of 5.7 and then squared. Drama, drum roll. Yes, comes up 1 always. So what happens is they're going to, in this section, they're going to give you a bunch of identities in this section. They're a bunch of identities. They will to prove them. You can say prove them. If that word prove frightens you, verify them with known identities. What are the known identities? Well, they're on the page 574. And I'm not going to copy them down because I think this is the third time they've shown these to you. I think they showed these in chapter 5 with an angle symbol, theta. Then they showed them in chapter 6. They used a T because those were functions, and they used T and verify they're putting in numbers. Here they're using a generic X. You don't need to know these names for them. But there they are. Okay, then here sine squared plus cosine squared is a 1. Tangent squared plus 1. We verified the or derived them. You divide through by a cosine squared and get this. Divide this one by a cosecant squared and you get this one. Actually, divide through by, cosine squared, you get to divide through by sine squared and you get this. Even odd shows you how to handle minus signs that are inside. We mentioned this, if you remember this, sine is odd, a minus sign will come out, a cosine is even, so you can ignore minus sign. The only new ones they didn't show you in chapter 5 and 6 are these cofunction identities they call. And again, just to pick one of them, we won't derive these right now, I just assume them. The sine of, say, pi over 2 minus x is identical to a cosine x. Again, this works for every x. Derive it. They don't really show you the formulas to derive it till 7.2, but they're giving you the identity now. Again, use x equals 7.8. So a sine minus 7.8 comes up exactly equal to a cosine of 7.8. Okay, let's see, a sine pi divided by 2 minus 7.8, 0.05395. Cosine of 7.8, 0.05395. So they are identical formulas, and if one comes up in the middle, if you see something like this come up, you can replace it with a cosine. They're exactly equal for any x whatsoever. This is an identity. So you verify identities by subbing in known identities. You can, in one of 3 ways. One of 3 ways. You can turn left side into right side. You can turn right side into left side, or you can work on both sides and meet in the middle. Meet in the middle. Work the left side down to something and then work on if you figure out what to do next, go to the right side, work it down and see if you can meet in the middle. All right, so it's something that takes practice, but we're going to start by simplifying trig expressions. just for practice. Okay, so page 575, you can try example 1. Simplify. A cosine of t, add a tangent t, sine of t. Okay, we're going to sub in known identities. Okay, not or sine or cosine. Those are fundamental. Can't be broken down. Can't be broken down. Can't broken down. So we're going to sub for tangent. And hopefully you remember a tangent can be broken down or subbed in for a sine t over cosine t. So we get cosine t, add sine t over cosine t times sine t. We're subbing this in for the tangent. All right, then you just kind of look and see what kind of algebra you can do. A sine times a sine would be a sine squared. So you get a cosine t, add sine squared t divided by cosine t. When you see two fractions, think common denominator. See two fractions, think common denominator, which is equal to cosine t. So you wind up with cosine t, sine squared t over cosine t. You're going to put this over there, cosine t over cosine t, plus sine squared t over cosine t. And if I put it over here under it to make the common denominator, I have to do it to the top times cosine t. So in effect, I've multiplied this by 1. Just chose to write 1 as cosine over cosine. Well, that gives us cosine squared t, cosine t, add sine squared t over cosine t. And now you see you can crush it together. Cosine squared t, add sine squared t, all over cosine t. And then this is going to come up all the time. When it does, you can rejoice, because hopefully you know that this equals 1. It doesn't matter the order. See, they can give you all kinds of variations of it. The usual one in the book is sine squared plus cosine squared, but you know, remember, it doesn't matter the order you add things. So even though it's reversed, you have cosine squared plus sine squared plus cosine squared. It's all still 1. So that's 1 over a cosine. And they will usually simplify that to a secant. So what that means is, so the original cosine t add tangent sine t is identical to a secant t. If you want to punch both sides, I'll just make up a 10.8. And you'd have to punch this 1 divided by cosine of 10.8. This, you punch cosine 10.8, add, that's tangent t, tangent 10.8 sine, just to give you some confidence in this. So cosine 10.8, tangent 10.8, oops, sine 10.8. So there's the left side. That was the original. Negative 5.14588. 888. And over here, 1 divided by cosine 10.8. And there you are, negative 5.14588. So you've turned the original expression into this and simplified it. It can be the original expression can be replaced with secant. Okay, so that's the kind of stuff that they're start, and then they're going to charge into actually verifying identities. You can pick some stuff off the homework here. Very first one, number 3. They're telling you write the trig expression in terms of sine and cosine and then simplify. Everything else can be broken down to sines and cosines. The sine and cosine are the absolute fundamentals. Okay, so 3, page 578, write in terms of sine and cosine. Simplify. So number 3 was cosine t, tangent t. Well, just like last problem, tangent sine t over cosine t. What happens is we usually just start plugging in. So that's a cosine t, sine t, divided by cosine t. So that's the sub in. We've broken everything in terms of sine and cosine. Simplify is to look at this and notice identical top and bottom. Those cancel, and it's identical to sine. Cosine times a tangent is identical to sine. If y'all can see that or not. Okay. We'll try another one. Number 7. Tangent squared, subtract secant, squared x. All right, again, same directions, right, in terms of sine and cosine, and simplify. Well, tangent, again, they can't give you every variation. So if a tangent is this, a tan squared is both of these squared. Over cosine squared of x. And a secant is 1 over cosine x, and it's squared. So this is the convert sines and cosine. All right, well, again, with fractions, you want the common denominator, sine squared of x, cosine squared of x, subtract, and 1 squared is 1, and cosine squared of x. Well, it has a common denominator. You didn't have to find one. It's already identical, so that's, you can crush together. Square root of x minus 1 all over cosine square root of x. All right, so how do I simplify sine squared of x minus 1? Well, it will simplify, know that, from sine squared of x, cosine, got to kind of work it out. from this? Well, I want the 1 and the sine squared on the same side. So a cosine squared, again, they can't give you every variation, is 1 minus the sine squared. Now I've worked it to where I've got it backwards. If I switch this order, sine squared minus 1, in effect, I've divided through by -1. It would put a negative over here, cosine squared of x. It's like dividing through by -1. 1 minus sine squared, divide through by -1, by -1, by -1. And there's a positive sine squared minus 1, and you have a negative cosine squared of x. So sine minus 1 is equal to a negative cosine squared of x. All right, so I can plug that in right here, and it gets me, coming down the page, and it gets me a negative cosine squared of x over cosine squared of x, which is equal to a -1. So finally, the whole thing simplifies to a -1. Tangent minus secant squared of x simplifies to a -1. Again, you could verify these things. I'll use x equals 2.7. Tan squared of a 2.7, subtract, and you'd have to punch a 1 over cosine squared of a 2.7. It better come up -1. Okay, you punch it again, parentheses, tan 2.7, close, and squared, and subtract. I have to square the 1 divided by, parentheses, cosine 2.7. Square that. Drum roll, better come up -1. There it is. I don't know if that proved anything to anybody or only to me. All right. Further down, in the next section, they're going to want you to just simplify. You're supposed to figure out how you do that. Should we try something maybe more, we could try a simple one and then maybe one like 21 before we finally get to the full Shimo. I guess we'll start with 13, simple one. We're off on page 579. Simplify. Sine x, secant x, divided by tangent. If you can't think of anything else to do, they give you, well, maybe I should show you the guidelines when we do identities. You can always convert to sines and cosines. And cosines. I mean, and, not so plus in the math sense. So you'd have sine x. A secant is 1 divided by cosine of x. Tangent was sine divided by cosine of x. Again, I'm just subbing in. Anytime you see a secant, you can replace it with 1 divided by cosine, and a tangent can be replaced with sine over cosine. I'm going to simplify each fraction. Sine x times the 1, that would wind up over cosine. Notice that you're dividing by exactly the same thing. You probably can see from here, you could sub in like a tangent here, tangent over tangent is 1. There's several ways to play these things. I'm just going to divide it out. Divided by cosine x, and then times, and you've got to flip this. Cosine x divided by sine x. You wind up with 1. So this whole expression then, the top equals the bottom. You can almost see it in your head. Secant 1 over cosine, so that'd be sine over cosine, and tangent is sine over cosine. Top and bottom are equal. All right. Why don't we try one like 21? Maybe we should flip pages in the middle. Sometimes these can get long. 21, page 579. 1 plus a cosine of y over 1 plus a secant of y. Simplify. Well, your top, you can't break down cosine, and adding 1 doesn't give you anything. This is equal to 1 over cosine y. So you have 1 plus cosine y, 1 plus 1 over cosine y. All right, well, you got all the kind of the same pieces, but they're not identical, top and bottom. These are not equal. You've got cosine and a flip of it. All right, so we're going to have to think common denominator on bottom. 1 plus cosine y over 1 over cosine y. You put that over here, cosine y, and put it up top, cosine y. 1 plus cosine y over cosine y over cosine y. 1 over cosine y. Maybe we should stop if anybody's following this. We can crush this together. Cosine y over cosine y plus 1 all over cosine y. You've got your top times flip again, flip over cosine y plus 1. Now I know that this looks switched, but I hope that doesn't bother you. Remember, the order you add stuff doesn't matter. So these do cancel, and you wind up with cosine y. This entire original expression can be boiled back to cosine y. All right. 27's got some nasty fractions, so does 23. Maybe I'll try 23. These are just kind of baby problems to get you used to messing with these identities. 1 plus sine u over cosine u. Add cosine u over 1 plus sine u. We're going to combine with a common denominator. So I'm going to put this together. Cosine u, 1 plus sine u. Put these together. Need both pieces for a common denominator. So in effect, you're sitting this over here. You're going to put that up there. Well, that'll be a 1 plus sine u, 1 plus sine u. And you're going to wind up putting this up there. Because you put it over here to form this, you wind up putting it up there. Cosine u plus cosine u, cosine u. If you individually try to think in your head cancel back, you wind up with this over this because that would cancel there, and you wind up with one of those cosines canceling cosine u over this. But don't put it back. You want to, I could write this as 1 plus sine u squared, but you may not be that familiar with FOIL. I might as well just FOIL this as is and then write that as cosine squared. So if I FOIL 1 plus 1 times 1, 1 times sine, Sine u times 1, another sine u. Sine u times sine u squared. Sine u squared. They'll write it sine squared u. Cosine times cosine, that's a cosine squared u. Cosine u, 1 plus sine u. All right, got examples of combining like terms here. Sine u times sine is sine squared, but sine u plus sine u is 2 sine u. This becomes 2 sine u. I hope you recognize a sine squared plus a cosine squared. It doesn't, again, matter what the input is, as long as it's identical, is equal to 1. That combines to a 1. Sometimes it'll come up in these problems, sine squared over here, cosine squared over here. There's a bunch of stuff in the middle. It doesn't matter. If you could group the stuff together, it's 1. All right, the bottom is still identical. 1 plus sine u. All right, combining your terms. One plus 1, 2 plus 2 sine u. Cosine u, 1 plus sine u. And you might start checking answers because, gee, it can't be broken down or whatever. But if you notice a common 2, factor out the 2. One plus sine u. 2 times 1, 2 times 2 sine u over cosine u sine u. The identical piece, that cancels. 2 over cosine is a twice secant u. The cosine's on bottom, it comes up as a secant. Basically, you're writing this 2 times 1 over cosine u if you want to really see all the steps written down, and that's a twice secant. This entire original, so 1 plus sine u cosine u plus cosine u over 1 plus sine u, and we boil down to twice a secant. Try to give you some confidence in this because that one was a lot of gibberish. 7-1 is problem 23. And 123. Yeah, there it is. Twice secant u. That's all they give you for the answer. They don't show you how they got there. But that's what you get for an answer. All right. Well, the whole schmo, so to speak, is the entire problem. Proving an identity. So verify, I don't know why they're calling them equations. That's you just said consider the identity, verify, algebraic, confirm graphically. We don't have to, that's just 29 and 30. Okay, they're just having you 29 confirm it's an identity. I don't think I put 29 on. Where's my assignment sheet? Oh, I did. Okay. Well, you don't have to worry about graphically. That's just graphing both sides. That would show that you get it. So we'll start with proving identities here. We can start with a super simple one. And then you get more complicated down the page. You've got time for a couple of them here. I guess I'll start with the first one. People get freaked out by the word prove, so I may just use the word verify. So what you get on this, page 579, say 31, verify the sine theta divided by a tangent theta comes up a cosine. Once again, it's just a game. You can, I'll repeat the three things. You can turn left side into right side, turn right side into left side, or work on both and meet in the middle. They give you some guidelines. Page where are they? Okay. Right here. Start with a side, pick one side, write it down, transform it to the other side. You start with a more complicated side. You're going to use these known identities. If you've got fractions, bring in common denominators, or if you are stuck, you may find it helpful to do sines and cosines. Okay, and they're trying to warn you, you're trying to prove an identity. You don't do algebra. You don't multiply through by numbers. You don't, like square both sides. And you're subbing in, again, these original identities that they've shown you here for the third time now, most of them anyway. All right, so something simple like 31. Again, we're going to sub in. This is the more complicated side. You can't break down a cosine. Sub in tan theta, sine over cosine theta. So I'm working on the left side here. So sine theta over sine theta divided by cosine theta. I kind of ignore this. I want to turn this in, hopefully, into that. So you get a sine the top times the flip of the bottom over sine theta. And you can see that the sines cancel, and you're left with the cosine, which is what you had originally. And it's about the only way to work something that simple. You can't break down sine and cosine. All right, are you ready for something maybe a little nastier? Try 35. You can see how many there are, and they even go on to the next page. I think I stopped through 59, halfway down the next column. Yeah, but I mean, you can work any of them if you want. I'm just trying to keep it something reasonable, because you also got WebAssign problems as well. Why don't we start on the next page? Verify. This will be about the last one I have time for. 579, tangent y, or verify. Tangent y over a cosecant y equals a 1 over cosine y, subtract 1 over secant y. I always wondered when I was a student, they said, who makes up these things? How does somebody even think of this? I never figured it out. Nobody ever explained it to me. All right, this is something you could work on both sides, and we may have to. But I, just tell you, you can break down tangent and cosecant. That's a sine over cosine. That's a 1 over cosine. But you're not going to bust it back apart to this. If you've got fractions apart, you want to put them together. So common denominator, you'll have a cosine y secant. You're like putting these together. So you want to put that up there. Secant y times 1, that's a secant y. I'll put this up there because you put it over here. Cosine y minus cosine y. Okay. I'm just taking a look at this, and I'm trying to turn this into this. Preference is to work on one side, trying to turn it into the other. If you again, I don't think, I've done a million of these. I have a crystal ball in my head. I'm just looking into my crystal ball. I don't really see turning this into this yet. Now, if I look at this, cosine can't be broken down, but the secants are 1 over cosine. So I got a 1 over cosine y there. Notice I don't write it down separately. Again, I'm trying to speed this up. Minus cosine y. And on bottom, cosine y. And 1 over cosine y for that. And notice you see a cosine. Basically, you're multiplying something by its reciprocal. You should get 1, and you do. So your bottom is just 1 here. And taking this, dividing by 1 over cosine y, and you're dividing by 1, that doesn't change any of this. You can drop the 1. So now I want a common denominator with this. So in effect, I'm moving this over here, and I'm going to move that up. So I'm getting 1 cosine y times cosine y all over cosine y. Hope this isn't moving too fast. You're putting a cosine y under here, and you're putting 1 on top. That puts cosine y times cosine y, which would be 1 minus squared y all over cosine y. Well, I hope you know a 1 minus cosine squared y is equal to a sine squared y. Again, coming from sine squared y plus cosine squared is 1. So I minus cosine squared y, 1 minus cosine squared y. Move that over, you'd subtract it. That's equal to sine squared of y. So this is equal to sine squared of y over cosine y. Okay, I've pretty much gotten to a point I can't break this down. Let's separate it out. You can bust it out to a sine y over cosine y times sine y. Again, I could work on this and turn it to this. It's perfectly legal. But there's my tangent y, but I've worked it to tangent y times sine y. Well, I got the tangent y, that matches. But I want it divided by a cosecant. So this is a case, mostly time you start with cosecant and sub in for sine. You can write this as tangent y times 1 over cosecant y. And if you multiply these fractions, you multiply the top, and you wind up with tangent y, and you're over cosecant y. Rest up. And again, there can be other ways to do it. There's not one single correct way to do these. I can't work every problem every single way. We would be here forever. I'm just trying to point out, I could have stopped here and worked this one down. You almost see it in your head. Sine y over cosine y. I'm sorry. Yeah, sine y over cosine y. Move this up would be a sine on top. So your sine from the tangent times sine, there's a sine squared over cosine, and that would have worked. So yes, there can be multiple ways to do these things, and that tends to drive students nuts on occasion. All right, I hope that's a good introduction to get y'all started this week, and we'll meet again on Friday. If y'all want to see any of these or have any questions, please join me on Friday. Otherwise, we're going to end the meeting.